Let me take you through this wonderful case study on filter integrated water bottle for CRPF Jawans. This title is very interesting. You generally have water bottles, but why should the filter be integrated in such a bottle? Let us go through the story of how this happened. We at the Design Innovation Center at IDC IIT Bombay have a mandate to take student projects to market. So we have this wonderful student of our MDes program called Devanshi. She was interested in working on a live project. So while she was working on this project, my team at the Design Innovation Center, both senior designers, engineers, environmental scientists, all would work together with her to see to it that while she works on the project, we also take it to the market. In the sense, the idea is that while the student is working on the project, we also support her so that she understands all the nuances of how the project can, really be realized in the field. So here, I'm extremely glad to show you this picture of our innovation studio where we're displaying this product for all the visitors to see, and also, give a clear, direction of what needs to be done when student projects have to go to the market. It all started with this wonderful initiative of the commandant of the CRPF forces who came to IIT Bombay and said, "Professors, you must come to our barracks, you must come to our site to see how difficult our conditions are. Then you decide what type of projects you want to work on." Professor Hemendra Arya from our aeronautical department went for such a visit with 4 other colleagues, and they were taken to the remotest of the CRPF camps. In this camp, Professor Arya was quite intrigued to see that the CRPF Jawans were actually starving for water, which is very unheard of. We always thought people would starve for food, but here they were starving for water. Let us see what he has to say.
Hello, I'm Hemendra Arya, faculty in Aerospace Department, IIT Bombay. I work in the area of mini aerial vehicles. Those are called as drones, and these can also be used for internal security. I'm also core faculty in the center which deals with the internal security, that is called as the NCETIS. So in this regard, some CRPF officers visited NCETIS and they gave their requirements for various issues which are related to internal security. They wanted to solve some problems. They explained me about a need for a water bottle which can help them in having a clean water when they are in operation. So I met some troops which are directly going to the field for long operations. And what I realized that typically they have to carry around 7-8 liters of water because they have to last for many days. And if you can imagine, if there's a summer, the water will soon get exhausted. They cannot come back without completing the mission, so they have to move forward. And then with thirst, they cannot perform as well as they would have performed otherwise. So keeping this in view, I asked them, what are their requirements? So they said, if a water which can last for a day and they can fill it up, which is a clean water, they will be very happy. I came back and told Professor Chakravarti to take it forward. And then Professor Chakravarti, along with me, we worked on this project with one student and we developed a CRPF bottle, which I feel it's a good product which will help them in having a clean water whenever they have a long operations.
Who are the CRPF Jawans? The CRPF is the Central Reserve Police Force, which actually goes to very stringent operations across the country, both from the borders and counterinsurgency. These counterinsurgency operations are really, really challenging. They also don't have any time limit. For example, when the Jawans set out to go for an operation, they think they're going to spend around 2 weeks, but finally sometimes they spend around 8 to 10 weeks in the field. So they have to do that type of planning so that they can really do the operation as well as come back safe.
सेंट्रल रिजर्व पुलिस फोर्स या CRPF आज भारत की सबसे बड़ी पैरामिलिट्री फोर्स है। जब भी हम किसी ऑपरेशन में निकलते हैं तो उस समय जनरली वो अपने साथ 7 से 8 लीटर पानी लेते हैं, या तकरीबन हमारे जो चलते हैं उनका मिनिमम एक्स्ट्रा वेट कैरी करते हैं 20 से 25 kg वाला। जिन सीजन्स में ऑपरेशंस होते हैं वो काफ़ी ह्यूमिड वाला होता है, स्वेटिंग से परेशान हो जाते हैं, लिक्विड्स की कमी हो जाती है। तो अगर इस लिहाज से अगर कोई ऐसा इक्विपमेंट हमें मिल जाए, ये जो रनिंग वाटर है जिसको हम स्टोर करेंगे उसी को फिल्टर करके वापस यूज़ कर सके, तो हमारे और हमारे जवानों के लिए काफ़ी फ़ायदेमंद रहेगा।
The most important aspect for the CRPF Jawan during such an operation is the load they carry. Though the duration is very long, they cannot really carry a lot of load. Hence, they have to keep on, worrying about how they can replenish some of their food, how they can replenish water. That brings out our challenge of what type of water bottle we'll give them. The total weight they have to carry amounts to 25 kilos, which involves their rifle, the rucksack with dry fruits, camp rations, and first aid. They have a bulletproof vest. Sometimes they carry in the rucksack, depending upon the situation, but they need to wear it most of the time. And 3 to 4 liters of water. And currently, unfortunately, they carry in, standard disposable water bottles, which are also upcycled, which is very unfortunate. When we teach design to students, we also encourage them to consider the worst possible scenario and start designing. In that particular condition, the student is actually working out very creatively, coming up with very, very out of the box solutions. And also, for example, they empathize with the users the most. This leads us to an interesting situation which I encountered during my 2 decades of teaching at IIT Bombay. To make the students understand all the nuances of innovation, I created these 7 concerns of innovation. I call it the Chakku 7 C's. And in these 7 C's, the first concern happens to be the cause. The cause, for example, is the resolve to solve a problem. In this case, with the CRPF Jawans, we wanted to take a resolve that we will actually give them clean, filtered water so that these Jawans will not starve of water. The challenging environment which our Jawan faces is that they have a very, very hostile environment. Sometimes the water bodies are even poisoned. Sometimes they can't even drink from regular sources of water because even the insurgents know that the Jawans are going to come there to pick up water and they could lay a trap there. So the Jawans have to really go to very, very remote corners, remote areas where even the locals are not drinking water and pick up water. And that water, they have to be sure that it is clean. So that is the basic premise of our cause, where we have considered that we will provide, filtered, clean water for the Jawans, for their safety and for their longevity. How do you think Jawans filter water currently? The Jawans, of course, use a lot of ingenious methods. They also use, special techniques which they are taught to them. They use cotton cloth for filtration. They use chlorine tablets, which expires in 2 to 3 months. So it's very safe for them to keep them good stock. And of course, they use water filter bottle where, currently what they use is AquaGuard on the go, which has a filter inside the bottle. And the biggest challenge they've told us was this filter starts smelling because the filter is already inside and the filtration is happening while you're drinking by pressing the bottle. This brings us to the second concern for innovation, which is the context. We all know that without understanding the context, there is no design. In case if there is design without understanding context, the design fails miserably. The context becomes extremely critical, and in this case, the context is paramount because here the Jawans are in very hostile environment and they are in very difficult situations. So understanding the problem space and the environment become very, very critical. I'm very glad that we could get this original pictures from our CRPF Jawans from their mobile phones. And here we can see the type of diverse areas they go to, from crossing water bodies to being on roads waiting for, people, or for, being in the jungles, as well as, cordoning off areas. So their operations are wide and, everything under what, happens in an operation. The current solutions in the market, which are available for filtration for our study purposes, are many. But will it suit our Jawans? The one which is shown here, second, which is the AquaGuard on the go, is what the CRPF commandant bought for the Jawans. But the Jawans were very unhappy, so they actually are not using that, and they are falling back on the upcycled disposable water bottles. So here we have a very challenging problem. When we looked at these filtration mechanisms and the type of bottles available in the market, after looking at all the bottles, we found out that this particular AquaGuard on the go, for example, was using a phenomenally good filter inside, for example. This filter was very high tech that when I squeeze the bottle, like the water which is already inside gets pushed through this filter and I can drink, directly from the top. In this case, we also notice that it has a capacity to filter 0.1 micron, particles and bacteria. So it filters bacteria, it filters virus, and the capacity also is 300 liters, which is very good for easily an 8-week operation. And we also want the Jawans to change the filter after every operation. And of course, you need a bottle, and the price is really, really good, where it is just $600. So here, came one study where we said, okay, this is a great thing, but the biggest challenge is that the filter is inside and it starts smelling because the water inside is already already dirty, or available water is picked up. So from here now, we have moved to a next stage where the student said, let me try out this filter. So we created this wonderful rig. Here again, it's interesting to see how a collaborative environment of professors from aeronautical, Professor Hemendra Arya, could give us very interesting insight from a completely different field. Professor Arya told us that he's seen this very small pumps which are used to fuel, the RC planes, the hobby planes which people fly. And he said, Chakravarti, why can't we use such a filter which can be pumped so that the water is filtered and it can go into the water bottle? And the CRPF Jawans are carrying filtered water. They're not carrying dirty water and then filtering when they're drinking, right? That's always a much better situation, because you go to fill your water from somewhere, and when you fill your water from somewhere, you pump and you actually filter there and then and carry only clean water. So that was a very interesting idea which Professor Arya had given. Let me quickly demonstrate to you how Devanshi quickly made a working rig. Again, it's important for us to understand that as soon as we identify technologies, as soon as we identify components in a design, you build a working rig to get a complete understanding of the various components and how things are happening, so that your project can take very good speed. The fuel pump to fill fuel in RC planes has some very interesting components. And we realized that this could easily be redesigned to fit in for the water bottle design. And we quickly opened the whole parts. We checked out what are the gearing mechanisms, what type of pressure it takes. And these are very important studies which will help us to take the project forward. From here, we move on to our next C, the comprehension, arriving at design insights. This stage is very critical because we have done a lot of study. We have understood the Jawans, we understood the technology, we understood the problem, we understood the problem space, we understood the environment. After all this, it becomes very critical that we, sort of get all the insights together and create a list for ourselves to understand and use these insights and effectively come with design brief, which will become the next C, which is the check. So in the check, Devanshi created this wonderful small, simple points where we said the bottle should be easy to operate, the bottle should be easy to carry, and some very interesting insights which he had were that the bottle should also, be easy to maintain, in the sense like, when you keep going to multiple operations, it should be, possible to maintain. So Devanshi, with this very minimal brief, Devanshi started building ideas. So she came up with this wonderful multiple ideas of, putting the filter inside the bottle again. Remember, though we had the problem of filter smelling, but some of the ideas are still inside. It's very interesting that though you have these problems, sometimes you think, okay, I can change the filter media so that it does not smell. So those are the new things which can happen. She had this wonderful cranking mechanisms, which are hand cranked, which are cranked before. Some of the ideas which are there could be actually using a bellow. So with all these multiple ideas, we have this very interesting method of affinity mapping. We do clustering of ideas as per the affinity of the ideas. So you may have some 100 ideas, and then we actually make maps of these ideas and bring clusters. So again, there's no hard and fast rule what you name these clusters as, but we consider these clusters as ease of use cluster. Then we also have the easy to carry cluster, and we have the easy to pump cluster. It's very interesting that in this case, we can actually have repeat ideas in some of them. It doesn't matter, because it's a creative process, and how we can merge ideas and take them forward is the most important aspect over here. So once we cluster these ideas, we have to choose one champion idea out of that and create a concept. A concept is an amalgamation of multiple ideas. So look at this wonderful concept which is simplified, where the Jawan is actually filling the regular water, whatever we call it, the dirty water here, just for convenience. He fills the dirty water in the bottle, keeps the bottle there, and whenever he wants to drink, the filter is outside and there's a hand pump, and with the hand pump, he puts the mouth there and he can drink from the hand pump. So this is easy to use because it's extremely convenient in his hand. Then the clustered idea is easy to carry. In this, you don't have any of the paraphernalia of extra pipes and extra pumps. Here the pump is a rotary pump, which is, the hand is shown rotating the pump, and you have the filter inside, and then you actually, put it in the bag, and it's very easy to carry. So this is the easy to carry concept amalgamated from multiple ideas. And then finally we have the easy to pump idea. In the easy to pump idea, here you have, like the way you can do reciprocating motion. You can do reciprocating motion, and you can actually, get filtered water, and the pipe can, go to the mouth, and you can start drinking whenever you want. Here also the dirty water is inside the bottle. So out of these three ideas, the Devanshi then worked on combining some of the advantages and removing the disadvantages, and then came up with this final design. It's very interesting that suddenly she jumped to a rectangular cuboid type of shape. And she kept saying that this shape would actually carry more water, is easy to put in the rucksack, because she wanted it easy to carry as our brief. And she built it. And she also did scenario building, where she went to a water body and she actually tried different ways of how this cuboid would actually be very convenient to use. She was really convinced that this will work really well. And of course, then she worked out on the various methods, or we call it the various ways in which you can do the filtration and you can do the cranking. So in this particular case, the filtration, as I mentioned to you, is happening by rotary motion, and the filter is built on the on the bottle. In this case, for example, the filter is inside the bottle, and the cranking is happening on the side of the bottle. This idea she came up after her study of various locations and various cranking. In this idea, she said, okay, the filter is smelling, so let me put the filter in the water and crank with an outside crank and fill clean water into my jar or into my bottle. And that's what you see in this concept, where the filtration happens outside. In this particular option, she said she would fit the mechanism, the pump mechanism in the bottle. The filter is outside, and the clean water will get filled into the bottle. The last option was selected as the final option because there was a lot of advantages in this design, where the filter is outside and the filtered water is inside, and the crank and the pump are well mounted on the bottle itself. And here it's very, very convenient to drink also, because you get only clean water to drink, and the filter is attached to the side outside the bottle, so it can get dried and there's no longer any smell. So from this, the student has to come and make a mock-up model. We encourage all our students to make mock-up models, because this makes you very quickly visualize the 3D form of your product. It also lets you, play, interact with your product. So she built this quick model, and with this quick model, she went and did further studies to find out how this can be used effectively. And in this particular case, you can imagine, because there's a thermocol model, not a working model, but how can she do a trial? But we actually imaginatively do a trial, and it's a very, very important stage of a design process. And then a very interesting thing happened. Devanshi went for the first stage presentation in IDC, and my own colleagues who were there in the presentation asked her very point blank, "Did you speak to any of the Jawans?" And the answer was no. And both the guide, which is me, and the student actually had no face, because in such a critical project like water bottle for a Jawan, we didn't even speak to one user, which is a big no-no in a design school. So that made us go and actually push ourselves and work with the commissioner. Luckily, I knew the commissioner from an earlier project. He was the Force One commando from Bombay, and then he actually took a posting to CRPF. So he was known to us. We called him up, and to the everlasting credit of Mr. Sadanand Date, we could actually get 5 CRPF Jawans in the studio with different type of experience. In the sense, the one, Mr. Mahale, who's in the front, is the senior commandant. The Jawans actually had 5 years experience, 10 years experience, 15 years experience, and 30 years experience. That type of Jawans we got in the studio, and it was such a wonderful interaction, and we learned so much in the project with this. Again, to the everlasting credit of our design process and the stage presentations and the focus of the faculty to understand users as the key became a very important component of learning in the design journey.
वाटर फिल्टर है, वाटर फिल्टर में इनके नैनो कार्बन ट्यूब्स लगे हुए हैं, जिससे कि वाटर फिल्टर होकर के इस बोतल में आएगा। वाटर को सक करने के लिए या बोतल में लाने के लिए एक पंप इस तरफ दिया हुआ है, जिससे हम खींच करके ये पंप से वाटर में मैन्युअली हम वाटर बोतल में लेंगे। तो मुझे एक शेप के रिगार्डिंग इसमें थोड़ा सा डाउट लग रहा है।
ऊपर की साइड में रहना ऑलरेडी बोतल ऐसे कड़ी रूप में रहता है, उस समय बॉडी के ऊपर अगर उसको रखने से कहीं लेटना पड़ता है, कहीं ऐसा कहीं डैमेज होने का खतरा है। तो सर इसको टॉप जो ऊपर का जो कैप के साइड में अगर ये फिल्टरिंग सिस्टम होने से और थोड़ा मजबूत रहेगा।
या तो इसके नीचे वाले कैप में एक अलग से अटैचमेंट रख सकते हैं, और ये जो ट्यूब लटक रही है उसको हम रोल करके उसमें लगा सकते हैं, ताकि एक कॉम्पैक्ट वाटर बॉटल हमें नजर आए। और ये पंप के रिगार्डिंग वगैरह कोई पॉइंट किसी का इस तरह का होना चाहिए?
ये पंप क्या सर, हम पानी में जहाँ से हम किसी पौंड से भर रहे हैं या नाले से पानी भर रहे हैं हम चलते चलते, तो क्या ये हमको फिल्टर हुआ पानी में डालना पड़ेगा?
ये पानी में डालना
उसको घुमाएंगे
उसी
अपने आप वो सक करके इसमें आ
जाएगा।
और कैप खुली होगी तो आपको दिखाई भी देगा कि कितना वाटर बॉटल खुल चुका है। और शेप के रिगार्डिंग वर्टिकल शेप मिनिमम 2 लीटर कैपेसिटी वाला, और हमारा जो यूनिफॉर्म का नॉर्मल कलर होता है उससे मैचिंग होता, साउंड प्रूफ रहे। और एक और भी प्रॉब्लम आता है, जैसे गर्मियों में चलते हैं तो कुछ समय के बाद बॉटल का स्मेल पानी में आ जाता है,
कम से कम 3-4 घंटे के बाद स्मेल आ जाता है पानी में, तो वो नहीं होना चाहिए।
From the valuable insights we gained from the Jawans, we went back in the design process, and we went back to our insights. We created new insights after the interaction, and we also, created a new check. So now we have this new check which has come up because of the insights from the Jawans, where to have an easy to filter mechanism, which is always there in the beginning also, should have an integral pump. They were very clear that the pump should not be separated out from the bottle. It should be part of the design of the bottle, and it should be easy to maintain and not smell, which was also there earlier. And we were thinking of storing less amount of water, but they said no, we has to have 2 liters of water. And again, a very interesting insight was they said it has to be soundproof. We were thinking that they were using these upcycled bottles, they make anyway a lot of sound. Can we also use, bottles which are lightweight and, but they said no, you can't use those bottles because they make a lot of sound. And when we jump onto the tarmac sometimes for operations, the bottle should not break. So they have to be really strong, and they should be possible to carry it in the side pockets of the bags. And the most important was that the cost should not go above 2,000 rupees. So that is, all a very important component of the design check. So after this, Devanshi got back to our thermocol models, did a lot of volume design so that we could store through 2 liters, but it can go into the side pocket of the CRPF Jawan's bag, and multiple shapes. How will they hold it? Where will the filter come? How will you open? How will the ventilation for the filter happen? So all those aspects were built in, and how the grip can be improved. So with all these inputs, she built multiple mock-up models, and we tried out with the bags. Again, Devanshi this time went to the unit in Kalyan, the CRPF unit. She borrowed their bag from them to see it, how it will fit into the bag, and all those aspects were considered. And then finally, the design shape was again enacted. Those are Devanshi's friends and classmates who are enacting in front with her to show how they hold, how they drink, and what happens with the bottle. And here, for example, interesting situation came up where Devanshi wanted the bottle to be easy to grip, because it's going to be, you're going to use the bottle to crank, right? The same bottle to crank. So she did this grip study, which is again, very, very well done, using current bottles, using new bottles. And look at the first 3 images where they actually, put this filter on top of a water bottle, and then, tried out, the cranking, and realized how much cantilever comes, for you to crank, because cranking is a lot of pressure, and that was working. And of course, that study was again done with the thermocol mock-up, and they found a lot of improvement when the mock-up was better. It was bean shaped so that it could sit on the lap very effectively. You can hold it very carefully, and these become a very, very important, component of the design process. Now, we learnt our lesson. We went back to the CRPF Jawans to even show these thermocol simple mock-up models, and we are very, very glad that they really liked the shape, they liked the size, and they said, wow, this is a good volume for us, and this will really be very helpful, and they approved the size and the shape. So with this wonderful feedback from the Jawans, we went back to our drawing boards where we wanted to create now, how will we fit the filters, how will we fit the tube, how will we fit the pump. Remember the study where we did the study of thermocol and putting all the pump and everything together. So with that study now, again we went to the stage of conception where ideas are generated to show what type of locations we'll have. The biggest challenge in all this is to make it as compact as possible. So to make it compact, we had to place the filter and the pump next to each other. That's one particular configuration. In this configuration, the height of the filter, which is standard, like we considered the height, we consider the same standard filter. So our total bottle height would, increase by this much. And then the filter had to be redesigned. The pump had to be redesigned to become vertical, right? It's a vertical pump. So this is option 1. And then, for example, we also checked out how will it be held, how will it be opened. Those details also are worked out. And then there is an option 2 where you actually put your filter and your pump one on top of the other. Like the way the sketch is shown. And so out of these 2 ideas, we were benchmarking to see which idea would reduce the height maximum. Then after the sketches were done, a very important component is to build quick working rigs. So we built the rigs to see how the volume shape works, and we realized from the pictures also you can see that when we placed the filter on top of the pump, it was actually taking less volume, and then we could reduce the volume well in that particular case. Hence finally it was decided to put the filter on top of the pump, like this. So finally, the design evolved into a final product where you have the you have the bottle, which is the blow molded bottle on the top. You have the base cap, which is holding the pump, and you have the bottom cap, which is holding the filter. So here you have the open condition to show how the the pipe is wound around the pump so that you could fit all the things in a very compact way. And of course, the filter housing is made in such a way that it has a lot of serrations, so air ventilation can happen and the filter media can dry. And the cap was supposed to be designed in such a way that the cap can never fall out, and even if you open, the cap will retain itself with that small string along with the body. And look at the small details which are done. The hook is given because they want to hang the bottle sometimes on their back. They would like to, also use it and tie it around on their haversack. Then the body serrations were given for better grip of the bottle. And of course, the perforated base cap, which I mentioned earlier. So this is the CAD model for the design where the filter and the pump are kept on one top of the other. So this is to show you how the actual pump works from inside. But when we improvise it in our design, we may have to change its location and how the whole organization of the gears and the pump is fitted. Now we come to our crafting stage, which is the sixth concern of innovation. Here we actually bring to shape all the ideas and the final concepts which we have considered. And in this case, the biggest help in today's technology is that we can use CAD modeling and use 3D printing. For example, this is the bottle from my 3D printing machine. We not even cleaned the surfaces yet to show that we could quickly, build our, bottles and your, mock-ups to actually assimilate and test whether the components we built are are as good as the insight we gained and the final product we selected. And then we actually worked out the animation to see, to explain how the water would be filtered. An interesting situation is that when you start crafting, your creativity is much, much better on sizing and proportions. Here, for example, remember, we were saying that this would occupy the least volume. But then when we were crafting, we realized that if you could place this next to each other, it is very low volume, much less than all the other options where we kept the pump vertical and this option was there. Then we had this option, and now there's the third option, which is an amalgamation where you have the pump, and the pump actually goes around this to make the volume low because this volume is very large. If I have to fit in the bottle volume, it has to become less. So in this case, for example, you can see how we now integrated the pump and the filter so that we can actually have much less volume than the volume which is placing the filter on top of the pump. So that's what is a very interesting situation, which I keep telling all the design students, that when you start crafting, your ideas and your creativity actually grows much more than when you actually do just sketching and taking things to a final concept. So here we have the final product renderings with all the details. You can see the bean-shaped design. You can see the hooks. The hooks are, my students are all formally very sensitive. You can see here that Devanshi used the collars of the CRPF Jawans, which are the shoulder flaps, which have become the bottle holders. These small formal cues are very, very important when you're designing customized products. And of course, the color is, the camouflage color of green. And then you have the ribs to hold, and you have the whole bottle, which is very compact, but still holds 2 liters of water. This is the image to show you how the filter and the pump are nested into one another. So the volume is further, the height of the bottle is further reduced. And this is just to show the internal mechanism of the pump, how it has been completely redesigned so that it can fit in a very small volume. And we have finally the approval from our CRPF Jawans. So it's interesting now that after our first debacle, we are able to go to our CRPF Jawans again and again and talk to them. They are extremely happy to give us feedback. And we are also very, very happy to get this feedback, especially because we wanted to take this project to the market and we wanted to see that the Jawans use this product when it is finally delivered.
तो इसमें फिल्टर यूनिट नीचे आ गया, ये बॉडी के साथ आ गया, इसमें पानी स्टोरेज होगा। ट्यूब का जो अटैचमेंट है फिल्टर के साथ, फिल्टर अपना पंप के साथ, उसको भी थोड़ा और मजबूत करने की ज़रूरत है, क्योंकि ये निकलने के चांसेस है।
अगर दोनों साइड में क्लिप होती है तो पकड़ के रखेंगे, ग्रिप 2 साइड में 2 ग्रिप हो जाता है।
हाँ, मतलब ये जो लॉकिंग मैकेनिज्म आपने किए हैं, इसको थोड़ा इम्प्रोवाइज करने की ज़रूरत है।
After all the inputs from the Jawans, we went to the next stage of model making, which is the prototyping phase, where you build a working model. This is a very challenging task, and for this we had to go and hire new project associates who had experience in pumping, who had experience in making miniature projects, because we had to build all the products together. So with that, we then again went into our 3D printing. We made all the parts come up. We created the gear pump, we created the pumps, and you can see how we built this working prototype. In the working prototype, the shape and size has to be same as your final product. So that's the challenge. Remember, we did a working rig, where the filter, we just attached the filter on top of a plastic jar and we cranked. Here, we created a working prototype where the shape and size of the bottle is exactly the same as the shape of the original design. So here, for example, I can show you this, this prototype. It's not even, the bottom is not painted yet. And this prototype has the crank. So you can crank, you can try it out. And then an interesting situation happened. When we actually tested the prototype, we realized that without priming, everybody knows that when you need to pump water, even in a regular pump, you need to prime the pipe. The pipe has to have water so that when you crank, it will fill the bottle. So we had to create the priming mechanism. So this is the priming mechanism which is there. So you actually prime the pump 4 times like this, and the water actually comes into the pipe, and then you start cranking, and then all your filtered water is inside the bottle. This is the working prototype we built, and we tested it out to see how all the things we thought about can work. In the design process, packaging plays a very vital role. Packaging also gives you information both about the product and how it has to be used and how it should not be misused. So here, I'm very happy for the support of our project designer, Dattaram Chari. By this time, Devanshi had graduated. So Dattaram Chari helped us with designing the packaging, and of course the bulk packaging box also, so that this bottle can really be cost effective when CRP Jawans will buy in bulk. We don't want to use, printed packaging, which could be expensive. So all these options were worked out, and then finally one was selected. So our most important component of multiple connections, remember, every time we were connecting with the user, we were going the iterative process. The 7 concerns were being met. Again, we went back to our conception, and again, now we are connecting back with the user. Now with this prototype, we connected back with the user. And here, for example, we went to our Jawans again. This time, our connection happened with the Jawans online, and we actually showed them our prototype, and again, took a lot of inputs from the Jawans. But a very interesting input was that they were asking us for 5 working prototypes. And now we made one prototype which was not as robust as 5. So now for making a pilot, so that I call a pilot production. So for going for a pilot production, I need to go to manufacturers who can actually build tools and build this pilot production for us. So I quickly went to manufacturers, and luckily we contacted a manufacturer who's the largest bottle manufacturer in the country, called Premsons, and Mr. Rambia was very, very supportive in this journey, and he quickly built the first blow molded bottle. This is the blow molded bottle which Premsons built for us, with all the logo, with all the ribs, and all design details built in. And from here on, we could go to our next phases of the pumps and the filter and the caps, which go for another process which the Premsons didn't have experience in. So we had to go to another small scale manufacturer to build all the other parts. So then a very important component of any design product is to have the specification sheet. So this is talking about all the specifications of the bottle. We are using the toughest material in plastics. This is a polycarbonate. This will not break, when you take it to the field, and it's going to last very, very long. And polycarbonate also is incidentally used for baby feeding bottles. And there the purpose is to have, sort of sterilize it. So you can also sterilize these bottles once in a year so that the jawans are always safe. I'm glad to mention that this project gave a lot of satisfaction to all of us, both at the Design Innovation Center as well as, for Devanshi. For her, it was her thesis project. The students at the end of their tenure have a design degree show. We got a lot of traction there where Devanshi presented her product, and a lot of people showed a lot of interest. And we're very happy that the Design Innovation Center team, we can see Aniket here who helped with the CAD modeling, Dattaramchari who was there with the complete design process, Ashwati in the yellow kurta, she's our environmental engineer who looked at the filtration, filter media and filter technologies, who all helped as a collaborative team to take this product forward. The design process of designing the filter integrated water bottle has been a very inspirational one, especially because of the sort of involvement of Devanshi as a student and the team at the Design Innovation Center, where we actually built multiple levels of mock-up, then the prototype, and then the working prototype, and finally it is going for mass production. We are also very, very happy that while this the product was being developed and while we got a lot of publicity in the newspapers, the word spread and we got various requirements from various quarters. The most interesting requirement was from Air Force. And we was wondering why will an Air Force, the people will need our bottles. And they said that they have these ground stations at various locations and they would like to use our water bottle at the ground location. Of course, the CRPF commandant from the materials division called up and they said they would like to have our water bottles for testing and evaluation. So they could place an order for a large quantity. So we are all still on the search for a very good vendor. Remember, we had built a collaborative team of small scale manufacturers to build the first, mock-up. In this mock-up, the bottle is blow molded, whereas the bottom section is still non-working. And then in the working rig, we actually have the bottle which is mass produced and the bottom section is actually built as a prototype. That is, it is not pilot production. So now we are working towards building the complete bottle by molding the bottom, creating all the gears, creating the filter mechanism, and actually building the complete bottle so that we could supply the 10 numbers which the CRPF Jawans are asking for, and then transfer the technology to any capable industry so that this can become the project for the future. We are working with potential manufacturers who have the capability to build such a product so that this project can see the light of the day and our CRPF Jawans can use this very, very effective bottle for their regular operations.